So we got a divide by zero problem here. That makes things complicated, but maybe if we expand here, there'll be something we can factor. So I'm going to kind of get lazy with limit notation here. This is 25 minus, if you expand this, that means you don't square each one, right? You don't square each term. You multiply it by itself. So that's going to give us 45x squared plus, this is going to be, whoa. 9 times 9 is 81. I was looking ahead. 9 times 5 is going to give us 45x. And then 5 times 9 is going to give us 45x. And then that's 25 at the end. So just remember, you got to distribute the negative sign. So that's negative 81x squared minus 90x minus 25. Okay, well, oh yeah, so 25 minus 25 makes nothing. And now you have negative 81x squared over negative 90x. Let's factor out an x. And you might be thinking, like, when is this going to happen in reality where I have something so that the 25s perfectly cancel out? We're actually going to see it in just a bit when we study the definition of a slope at an instant. It happens all the time when you evaluate it using limits. So in the numerator, we were left with negative 81x squared minus 90x. We were able to factor out an x. The x's cancel. And so now we don't have a divide by zero problem. Now we can just plug in 0. Because it's not a piecewise function, doesn't do something crazy all of a sudden, and when x gets closer to 0 from the left or from the right, has the same basic behavior. So if you plug in 0, this is gone. You got negative 90 over negative 10, so this limit is just 9. So we're asked to evaluate this limit as x approaches negative 4. Let's see if we're lucky and if we can just plug in negative 4. Because if we can, if there's no divide by 0 issues, then we're all set. We don't have to do much calculus. This is negative 80. Negative 23 times negative 4 is going to make positive 92. Oh, there's our divide by 0 problem. So we can't evaluate this limit right now. But what we could do is we could potentially factor the numerator as a trinomial, factor the denominator, and then try plugging in x equals negative 4 if something cancels out. So this limit is equal to factoring the numerator. Remember, the old trick was to multiply the first and the last coefficients. That's 72. We're supposed to find two numbers that add up to be 6. Oh, sorry, that's a negative 72. Two numbers that add up to be 6 but multiply to be negative 72. Here's where I start guessing. Oh, that wasn't what I wanted to type. How about negative 6 and 12? Because negative 6 times 12 makes negative 72. Negative 6 plus 12 makes positive 6. So the numerator becomes 3x squared minus 6x plus 12x minus 24. And then factoring the denominator. Actually, I just realized we could have factored out a 3 to make it a little easier, but we'll figure that out later. Maybe it'll still turn out okay. First and the last here, negative 5 times negative 12, that makes positive 60. Two numbers that multiply to be positive 60 but add to be negative 23. You got to multiply to be positive 60, add up to be negative 23. So how about negative 20 and negative 3? Multiplies to be 60, adds up to negative 23. So this is now negative 5x squared, subtract 20x, subtract 3x, minus 12. So that's the limit. Still as x approaches negative 4. Factoring the top by grouping, putting these in a group can factor out a 3x. I'm left with x minus 2. And then here you can factor out 12 from both of those, so that's x minus 2. Factoring these by grouping, I'm going to factor out a negative 5 and an x. We get x plus 4. And then here I'm going to factor out a negative 3. So we get x plus 4. And that's the whole point of factoring by grouping and finding this special number, right? Because now at the top I can factor out an x minus 2. And that leaves me with 3x plus 12, which could be simplified. We could take out a 3 from it. And on bottom, I can factor out an x plus 4, and that leaves me a negative 5x minus 3. Uh-oh. Nothing canceled. Oh, something will cancel though, because look, if we factor out a 3 from this parentheses, that becomes 3 x plus 4, and we got a 3 on the outside. So look, the x plus 4 and the x plus 4 cancel, and now we don't have a divide by 0 problem if we were to plug in the value of our limit. So now we can just plug in -4. -4 minus 2 makes -6. -6 times 3 makes -18. -4 times -5 makes 20. 20 minus 3 makes something. 17. Looks like that's it.